akili.
Semen collection area whereby we collect it from several bulls. These are all breeds that we have here. We have the most ones are Frisians, Ashers, Jersey, Guernsey, and beef breeds. Also, we do have crosses. Here at Semen collection area, we identify the bulls based on demand and the shortage in stock in our storage facilities. Also, we collect some specific bulls based on demand from some farmers and some groups. Here at collection, we also identify healthy bulls so that we can collect from them. And here we assemble our bulls. Since we have restrained them from their feeding areas, we assemble them in a ring manner around these rails that you see. Also, the bulls that we are going to collect from them must be clean, sterile for the quality semen to pass. The third jump will be now the real semen collection. We use an heavy equipment, artificial vagina, for our semen collection, which it has been prepared overnight. At least we heat it for up to 40 degrees Celsius overnight. We protect our semen from UV rays by having an outer case for protection. At least the heavy should be inside the casing so that it cannot be affected by UV rays. As we finish the semen collection, we will give the sample to the laboratory whereby it will be examined and further processing. Thank you.
So after harvesting of the semen will be brought in through this window, and then we put it in a water bath at 7 degrees centigrade to maintain the same temperature as it is in the testicles. Then from there I want to record all the information about the semen ejaculate. I will record the name of the bull. I also record the breed of the bull, the ejaculate that I'm dealing with. We collect 2 ejaculates per day, ejaculate A and ejaculate B. Then I will record the time when the ejaculate has come in. The next thing that I record also is the volume of the semen that has come in. And then after that, we want to start evaluating the semen. And in evaluation of the semen, I'll take a sample of the ejaculate using a micropipette. I'll take a small drop and then put it on a microscope slide. I'll put 2 drops on the microscope on the slide, and then cover one of them with a cover slip to spread out the spermatozoa so that I can be able to see the individual spermatozoa. Then I check the sample under the microscope at ×10 magnification. And the first thing that I will check is the mass motility. How are all the spermatozoa moving together? And I'm able to assess the mass motility in terms of if all the cells are dead, then there is no mass motility. If the cells are in progressive motility, then there is vigorous mass motility. And that indicates that most of the cells are in progressive motility, and that's what we want. The next thing that I want to check is the individual motility of the spermatozoa. I will still check it at 10 magnification. I need to move the slide. And I am able to assess the motility the individual motility of the spermatozoa, and this one I rate it at 80%. Our cutoff is 70%. Any progressive motility less than 70%, we do not take it for further processing. Anything above 70%, we take it for further processing. In the meantime, the technician will be measuring using the photometer. We shall measure the concentration of the semen. The concentration of the semen and the volume of the semen will determine how many doses of semen you can be able to make out of that ejaculate sample. The one that I have just assessed now, and that is the bull sunny boy. The concentration is 1.623 spermatozoa per mil, and the volume of the semen is 3 mils, and hence out of that semen ejaculate we shall be able to prepare 222 doses of semen. And in it, the next thing that we do is to extend the semen, and we use Opticell, an imported product. And Opticell contains, it will contain sucrose that provides energy to the spermatozoa. It will also contain a cryoprotectant, glycerol, that coats the spermatozoa, preventing it from cold shock. It also contains ions, which balance the pH. The pH of semen is at 7.4, and the ions will help balance the pH at 7.4, because if it is too high, it will kill the spermatozoa. If it is too low, it will kill the spermatozoa. Once we do the dilution of the Opticell with the distilled water, then we can go ahead and extend the semen sample. And we are going to add to the semen sample 44 mils of the Opticell mixed with the distilled water so that you can extend it. The next thing that I want to do is to shake the semen after we have diluted it, because anything could happen. The buffer itself could have a problem and then kill the spermatozoa.
So we use sodium chloride, 0.9% sodium chloride, then 20 mils of semen. Then the machine will calculate the concentration, the buffer, or the amount of buffer to be used, and the number of doses that will be produced out of that semen. So our semen volume is 3 mils. So I'll take 20 mils of the sample, place it in a cuvette with sodium chloride. So this is a cuvette with sodium chloride. Place it 20 mils. Then I shake it twice for homogeneous mix. Then I place it in the photometer, calculate it. I file the machine, inputting the volume of the semen. For our case, the volume was 3 mils. Then I'll validate the machine. Then finally it will give me the concentration of the semen. So we give some seconds for the machine. So in this case, our concentration is 1.9 billion spermatozoa per mil. Okay, the amount of extender we use is 59, and the number of doses that will be produced out of 3 mils is 271 doses.
Here we are doing dilution, and also the water bath at 7 degrees, just as the other water bath that we have had the other area in the microscope stage is at 7 degrees. So we are maintaining the temperature at 7 degrees also at the dilution point. We are going to use the optic cell diluent to dilute our semen. And we also have to mix this with a ratio of 1 to 2 to water, which is sterilized water. So I have measured my diluent here. It's at 70 mLs, and the water I have measured at 140 mLs. So this is a ratio of 1 to 2. They were initially pre-warmed at 7 degrees, and so I still just swirl it a little, then take it back to the water bath to maintain the temperature. So this buffer is an import, the one that we're using. It is meant to extend the life of the semen, and it's a feed for the cells that are in the sample. So this one it cushions the cells from shocks, because after this we're going to drop the temperatures to a low temperature. So this buffer here will buffer the semen from any kind of shock that is going to get later. And it also has glycerol molecules that is going to give energy to the semen, so that it doesn't die eventually as you're processing the semen. So that is why we're using the buffer. And also the importance of this buffer is also to extend the semen. Okay, from the photometer reading, we got that we need to get 233 mils of the buffer to be added to the sample. And so you're going to measure 233 mils to be added to the sample for it to be enough to make the number of doses that are supposed to be required at the end of the process. So we'll take the sample here. It is well labeled as Robin A. And then we take our flask, conical flask, that is also warm at 7 degrees. We put a label, not to forget the bull name and the specimen number. The flask is well labeled as bull name and the specimen number is this. Then eventually now, we will measure the number of mils that were read from the photometer. We are supposed to use 233 mils from the photometer reading. So I will measure. You wrap it carefully to avoid any water meeting the semen. There we go, with the 233 mils. Now I'll pour in the flask half of the buffer first to offer cushion to the semen. Then I'll pick the semen from the water bath. I'll wipe it again to avoid any water contact. Now pour it gently into the flask. Then rinse the tube with the buffer. Then I'll pour in the rest of the buffer. And cover it. So this is what we get after diluting this semen sample. You see, now you can achieve the number of doses from what read from the photometer, according to what the photometer gave us. Now, after dilution, we now put it in our water bath. With the warm water still, to the level of the semen. And then you let it rest for about 20 minutes at room temperature before you continue with the process.
And we have mixed it with the semen, and the amount that we measure of the buffer is determined by the photometer. According to the photometer reading, we are supposed to add 48 mils of the buffer. We added to the ejaculate sample of Sunny Boy, bull Sunny Boy. And once we do that, we are going to take a sample now of the bull Sunny Boy to check whether the motility is still good after the dilution. So using a micropipette, I'll take a sample. Put it on a slide. Cover it with a cover slip to spread out the spermatozoa, and then I shake it under the microscope at magnification of times 10. Then I'll be able to assess the individual motility of the spermatozoa. The motility is still good. I would rate that one at 85% of the spermatozoa are in progressive motility. I'll go ahead and record this information in a semen dilution card. And then the next thing that we do is to take the semen sample to a fridge at 4 degrees centigrade. The semen sample will stay there for the next 4 to 6 hours. And we call the process sterilization process, whereby the glycerol, which is a cryoprotectant, is allowed to coat the spermatozoa, preventing the spermatozoa from cold shock or low temperatures. After that, the rest of the processing will be done using the MX machine. That is the filling of the straws, the sealing of the straws, and also the printing of the straws.
CASA, computer-assisted semen analyzer. It's used to analyze semen to give us different parameters of the semen. We take semen 10 mils. We use the ledger slide. It's a tempered slide. It has different tempers, so you use different tempers for different semen analysis. So in this case, you place your ledger slide on the temper, you input your semen, then you allow the machine to analyze the semen. It's computer assisted. That means it's automated in such a way that it analyzes the semen and gives you different parameters of the semen, like the proximal distal droplets that they are found in the semen, the progressive motility of the semen, the motile semen, and the one that they are static. So we are going to take a sample of the semen. So I'll take a drop of semen. Then I'll ensure that I cover it well. Then place it in the chamber. For this case, I'm using chamber B. So our machine again has different chambers as compared to the ledger slide. In this case, we have chamber A, B, C, and D. So the chamber that you have input the semen is the one that you will use on the machine for screening. So in this case, I've loaded the semen. So I load the ledger slide of the machine. Then I'll go to chamber B. In this case, when I use chamber A, I'll go to chamber B, where my semen is. Then I'll use, so this is diluted semen, in this case, so we have the semen there. So in case I want to see the different fields, I need either to choke in or choke out to see the different fields before analysis. Then what I need to ensure again is that the illumination of the machine should be well illuminated. In that case, it should be at 65%. And the temperature of the machine should be at that 7 degrees. So from there, I need to capture at least 6 fields for the machine to analyze the semen well. So I'll capture 6 of them. So we have, one, we have the second one, we have the third one there, we have the fourth. Okay, so need to analyze more up to 6. We have the fifth. And finally, we have the last one, the 6th one. Then when you're done analyzing the 6 fields, you need to input the information of that bull. For in this case, you need to take the information from our semen and you input them in the machine for it to analyze and give you the report of that semen. This case, our animal species was a Frisian. We have the animal ID as was Nikon A. Sorry, it was Robin A. Then ejaculate, we have ejaculate A. The patch number is the date that the semen was collected. For this case, it's 12 today, October 2022. Then the volume of that semen, it was 3 mils. Then the sample volume, then the collection technician. In this case, I need to. Then we have the lab technician. In this case, I'm the one analyzing it. Then from there now, I need to save the sample and give a report. And before saving and giving a report, I need to check on one or 2 fields. So for this case, let me just analyze one field, like that field. So these are the semen that they are found in that field. There are others that they are motile. We have the progressive, and we have the one that they are static, they are not moving. So they are represented in different colors. For this case, I need to take even this red color for that case. So that means that semen is static, it's not moving. Then I can go back and take another different semen. So for that case, it's progressive, it's motile, and it's rapid. So it's moving forward. Then I can just analyze the last one. For this case, I can just use this one. So this one shows that it's a late track, moving to the frame late after analysis. So we can go back now and report and save our sample and report. For this case, there is a certain percentage that we need to have for it to save the report. So for our case, our semen volume is less than the one which is required for it to analyze. But in that case, we can still say, no, we need to save the report and get the report out of that. So here is the report. You can take the report. It shows the motility of that semen, the total volume of that semen. There's the one that they are static, the one that they are progressive, the motile, and the slow ones. They are under the morphology of that semen. It gives us the ones that they are the pen tails. The percentage is 1.1. The one with coil tails does 1.1. The distal midfield reflex is 1.1. We have the distal droplets, 4.2, and the proximal droplets as 3.2. We have the dosing there. Thank you. Fridge for 4 hours at 4 degrees. So our semen is ready, 4 hours at the fridge. We need to carry out now a filling of the semen into the semen straws. And here we use a machine known as the MX4 machine. It's a machine used to fill semen into the straw. It seals that semen straw, and finally it seals, it prints the information of that semen into the straw. So I'll take you, this is a machine which is automated. It uses the computer. So if I can show you, it's computer assisted in this case. The computer contains all the information about the bulls. So we need to select the bull that we are filling into the straws. So in this case, I need to fill to search for the bull. So our bull was Robin A. So I'll take Robin. Okay, so we have, in this case we have Robin. So in this I need to select. Then before printing now, I need to go to the machine, check whether the machine, I need to check whether the machine has all the details, has all the required equipment. Then we have now our machine, the MX4 machine. You have seen the machine does three things at the core. The first thing, it fills the semen into the straw. Second, it seals that semen straw. And finally, it prints the information of that semen into the semen straw. And this machine, we have two sides. The first one is the side for the pressure, and we have the hydraulic machine. That's side here we have the hydraulic machine. That's the one. It supplies the pressure to this machine. Then pressure now builds at this machine through this suction side. Then our semen is placed in this cone, sucked by these tubes, flexible tubes. Then finally we have our, for this case, we have these nails for filling the semen into the straw, and we have this other one for applying the pressure for the semen to be sucked into the straw. I'll take one straw to show what we have. We have two ends of this straw. We have the industrial end, which is sealed with a cotton, and we have the laboratory end, whereby the MX4 machine now will seal. So this is already sealed, and it's used to supply now the pressure to this machine for the semen to be sucked into the straw. Okay, so we now pour our semen into this cone. So first of all, we need to wipe. You need to shake for mixing well, and you need to wipe it well to avoid any contact of water with semen. Then you place it. You need to place it well, slowly. Then in that case, the remaining you can still close it. Then from there now you need to select now and command the machine to print the information. But before printing, you need to check whether our machine is okay. So you can come start here. You need to initialize the machine, and you see whether our straws are in good order. So you initialize the machine. Then you advance the trolley. Okay, then from there now, you need to activate your straws. Your straws need to be in good order. Then I need to come here and activate my straws. You can see how the straws are being arranged by the machine itself. Then from there now, you need to send. You need to command computer to print. Okay, then we wait now for the machine.
kufanya quality control.
The semen arranged on the racks like this. They are stacked up to 30 racks. They are now ready for freezing. So we'll begin our program first. Because this MX4 machine was at 4 degrees, so the freezing has to begin at 4 degrees also. So we'll begin the freezing procedure to get to 4 degrees first before we begin the freezing of the semen. So far we'll check for the pressurized container that has liquid nitrogen. To check if it has liquid nitrogen, we'll check here at this point. It has liquid. Then we can now open the program, the liquid nitrogen from here. We cover this freezing chamber for it to attain 4 degrees. It all begins at this point here. We depress the heat, fans, and liquid nitrogen supply so that it goes into the chamber for it to cool down to 4 degrees. Then after it is down to 4 degrees now, that's now when you can begin to freeze our product. We go back to the racks over here. First of all, you open the chamber. We take the racks that are full of straws, take it to the freezing chamber, and then we pick a sample of 1 straw from the chamber. You cut it, you put it in the probe like this. This one will reveal the product, how it is freezing. After putting the probe there, you can now close it down. And continue with the freezing. Now the freezing will start from 4 degrees now, as it drops all the way up to negative 140 degrees. That is now, the freezing will now be complete. After that, you'll stop the program because there'll be an alarm here telling you that the freezing is now complete. Now you'll stop the program, you open the chamber, and then we will collect our frozen semen like this. Then put it in goblets. And now we put it now into a container of negative 106 degrees.
Okay, get started.
So we have just loaded the semen that we were filling the freezing chamber. Now we are waiting for the temperature to stabilize because the freezing process has to start at 4 degrees centigrade. So we are waiting for the chamber to stabilize, the temperature to stabilize at 4 degrees so that we can start off the program. We start it when it's not ready, it will not start because the entire system is computerized. This freezing container is actually controlled by this computer here. So it's a whole computerized program. So we'll try to start. Because it's ready, we have started. The temperature is already stabilized at 4 degrees. So we have 2 curves. The theoretical curve, the theoretical temperature, the temperature of the chamber, and the product temperature. The product temperature basically means the temperature of the semen that is already inside the straw. So we expect 3 curves. The theoretical temperature is the one that guides us and is always in yellow. So then the red one and the black one should follow almost the same curve, all the way up to negative 145 degrees in a period of about 8 minutes. So it's now going down slowly. The curve is set in such a way that the temperature drop is not all that rapid initially, but as it gets to the 4th minute, it can now drop a little bit faster. So meanwhile, as we wait for the temperature to go down, we usually prepare the containers where we are going to store the semen. once the freezing process is over. That is what we are going to do. So you take a break because the temperature should not go below 130 degrees. That 130 degrees. Continue because the temperature has dropped again. No.
ADC Livestock Genetics Centre. Excellence in breeding, excellence in breeding. Biu ya mgambo ikilia, kuna jambo. ADC Livestock Genetics Centre wanakupatia ndama mwenye nguvu, ndama atakaye kupatia maziwa zaidi ya lita 25 kila siku. Sasa kila mkulima anaulizwa aweze kununua mbegu za AI, yani Artificial Insemination, kutoka ADC Livestock Genetics Centre.